Did you fix it? Good.
Yeah, we had problems.
I'm glad you got it fixed. All right, now, I got the two recorders going now, so there should be, if I can do it today, I tried to do it the other day. I tried to load both of them, but I could only get one to load, so I don't know what happened to the other one. I'll try to load it today too, where there'll be two recordings, just in case something happens to the other recording. I'll have two. So, and seems to me that this microphone is working better, so I don't know what the difference is. I haven't done anything, so I don't know what's up there. So anyway, everything's running, and let's get to the whiteboard, and I want to go over 5.2, which is just positive and negative numbers, which is not a big deal. Just a little bit of review over some pre-algebra stuff that y'all should have learned back in pre-algebra. Okay, so I think I got both things going. I'm pretty sure I got both things going. I'm sure I do. All right. So, with positive and negative numbers, the one that you really need to learn, the one that's not so easy, is adding and subtracting. And just say integers. Integers is a 25-cent word for positive and negative numbers. Okay? So when you're adding and subtracting positive and negative numbers, all you got to remember is what's most important to us. And that's what? Money. That's all you got to remember. There's only 3 rules that you got to remember. Ready? 1. When you have a positive, that means you have it in your pocket. When you see a negative, that means what? You owe that money. And when you see 2 negatives together, 2 negatives right beside each other make what? A positive. All you got to remember. I don't care what sentence you give me, those 3 rules will apply. So let's think of something real simple. All right, 5 plus a negative 3. You don't have to sit there and say 5 plus a negative 3. If you do, then you just say to yourself, I have $5, and I what? You owe 3. Now, if you owe me $3 and you have $5 in your pocket, what's the outcome of that situation? You have $2. You pay me off, and you have $2. How do you say have $2? Positive 2. Let's say that you have this, negative 3 plus a negative 4. This means that you owe $3. This means that you owe $4. Now, if you owe me $3, and you owe Miss Burton $4, what's the outcome of that situation? You owe $7. Don't sit there and say, oh, I have $7, it'll be positive 7. What world do you live in? If you owe Visa $200 and you owe MasterCard $400, you don't have $700 in your pocket, or $600, whatever I said. You owe Visa and MasterCard. If you owe somebody $3 and you owe somebody $4, you owe what? $7. That's all there is to it. I guarantee you somebody's in it. My teacher taught me that if you do, you add negative and, well, you didn't get your money's worth. Because all that's a bunch of crap. Well, what if you have this? Negative 4 plus 7. You owe Walmart $4. You have $7 in your pocket. If you owe Walmart $4 and you have 7 in your pocket, what's the outcome? You have 3. If y'all want to make this complicated, I guess we could make it complicated, but I'm not going to. That's it. Well, what about when you have -4 minus -2? Well, what did I tell you about two negatives together? Take your red marker, turn that into a positive, and you back to the beginning. You owe $4. You have $2. If you owe Walmart $4 and you have $2, this happened to me at Walmart yesterday. I had to get some caramel sauce yesterday. And I went to LA Walmart, which is depressing as depressing can be. And there's about 200 people in the LA Walmart, so that means we have 2 registers open. So I'm standing at the one that's on the far left end. When you come into if you stand in front of Walmart, the right-hand side, near the garden center, I'm standing at that right beside Health and Beauty Aids. That can register right there. And there's like 15 people in line. And I get to the person, 2 people in front of me, and she's buying 2 or 3 things, and she pulls out her money, and guess what? She doesn't have enough money. Well, I didn't know how much she needed. I was just watching, and I didn't know how much she needed because I was 2 or 3 back. I would have done that because I had like $5 in my pocket. I would have gave it to her, but I didn't know, and I only looked right when she was looking. I thought she was looking for a ID for something because she was looking all in her pocketbook and everything. But anyway, she owed $4 and she only had what? 2. Now, if you owe Walmart $4, you're at the cash register, and you owe them $4, and you have 2, what's the outcome? You still owe Walmart what? $2. Now, do y'all see what I'm talking about as far as money? There is no reason for anybody to get these problems wrong if you think of money. If you sit there and think of all these rules that you tried to learn back in the 4th, 5th, 6th grade, you can forget it because you're not going to remember those rules. You might remember them, but you're going to be confused. Just remember money and 2 negatives make a positive. That's all you got to remember. That's it. Can anybody give me another one that you might think is complicated? You can do 3 or 4. 4 minus 6 minus -2. Well, the first thing you're going to do is rewrite this because the 2 negatives make the what? So you take your handy dandy virtual red marker and turn that into a positive. Now you've got 4 minus 6 plus 2. And you go left to right. So 4, this means you have. This means you what? You owe. And this means you have. So how much do you have in all? $6. How much you owe?
6.
So what is that? Break even. If you owe Walmart $6 and you have $6, you walk out of the store with whatever you got and no money. I don't understand how teachers can make this complicated. But if you think back, they made it complicated. And we, especially you women, I worked at Walmart for 3 years, okay? 396, which is now up on Liberty Highway. Used to be beside the mall. And sometimes I'd have to run up there to do the cash registers, like at Christmas time or something. I'd have to go from Sporting Goods, I'd go up there and run the cash register. If the bill was $10 or $9.52, and I got to talking, and I give you back change of $5 and so cent. How long does it take a woman to figure out that I've shortchanged her? A nanosecond. It takes women a nanosecond to know that I've shortchanged them. And I saw that long before I became a teacher. When you put positives and negatives, if you associate most of your math with negatives, with money, oh my gosh, it's just like that. Just like I asked you, what is 6 times 25? You reach for a calculator. I asked you what 6 quarters are, you tell me it's $1.50. Well, 6 times 25 is 150. But you use a calculator for one and you don't use a calculator for the other. Money, 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 money. Now, what about multiplication and division? Well, that's pretty simple. Why is that simple? Because with multiplication and division of integers, all you have to remember is what? The 2 rules. Like or what? Positive. Unlike is what? Negative. How do you like that, unlike? Unlike. I can't even spell. I suck. Okay? There. Unlike is negative. So what's negative 4 over negative 2? Well, it's like sign. So your answer is positive 2. What's negative 21 over positive 3? Well, that's unlike signs. Have you ever jumped off a car before? Okay? Well, I'm going to tell you how to do a car. All right? How to jump off a car. Here's your battery. There's 2 posts on the battery. One has a positive on it. It's usually on the battery. You look for it. And the other one is what? Negative. And it has a little negative. So y'all look at this now. That way when you need to jump off your car, you know how to do it. And here's another car battery. The one you're going to jump off, or maybe I don't know which one's dead or which one's what. But it's got a positive and it's got a negative. Now, how many of you have seen jumper cables before? What color are the jumper cables? Red and black. All right? Red is usually hot. That's what, when you think of red, stove, hot, red. Stop sign, red. Okay? So red goes here. And red goes there. So red goes to positives. And then the black goes to what? Negative. Now, that's the general way of doing it. And that's how you jump the car off. Okay? What happens if you switch it? Well, you'll get sparks, and it'll scare the crap out of you. You look like you're welding. Alright? Now just remember, the unlike, that don't end up too good. Negative. When you have unlike signs, see, these are like. Positive goes to what? Positive, no sparks. It'll be sparks, but not much. Negative to negative, no spark. So you put this negative to this positive over here. You better not leave it on there very long, you're going to burn your alternator up. Okay? But as long as you do it like positives, like signs, no what? No spark. Unlike signs, spark. Spark is good or bad? Bad. And that's how you remember unlike signs. So you can do it with multiplication. 2 times negative 4 is what? You got a negative. You have a positive and a negative, negative 8. Negative 2 times negative 3 is what? Positive 6. You got like signs. Like means positive. How is your brother? That's what you want.
Yeah, I'm going to see them after this class.
Oh, good.
They're so hot. No, she's out.
Now, let's move on to the end of 5.3, which is multiplying and dividing what? Fractions. And then we're going to put it all together. So, if you take multiplying fractions, there's two ways to multiply fractions. One is to multiply and reduce. And what's the other way of doing it? To reduce and what? Reduce and multiply. Now, which one can you do all of the time? This is the one you can do all of the time. You can't do the second one all the time. So here's an example of multiply and reduce. 1 over 2 times 3 over 7. Okay, there's nothing to reduce. So I just go to multiply. 1 times 3 is what? And 2 times 7 is? Can I reduce 3 and 14? No. And you know this because you know your prime factorization. Okay? Remember what I said about texting and using your phone while I'm talking. Okay? Because if you're come up here and ask me a question, I'm going to text while you're talking to me and see how you like it. Okay? All right, that's a warning shot. Second time I'll embarrass you. All right, so here's another one. 1 over 2 times 4 over 6. What's 1 times 4? What's 2 times 6? And what happens with 4 and 12? What can you do with 4 and 12? Why? How do you know? They're both even, and you know that from the previous section 5.1. So divide by 4, divide by 4, you get 1/3. Now this is an example of what? Multiply, then what? Reduce. So this is multiply and not reduce because you can't, and this is multiply and reduce because you can reduce. So that's this one. And you can do that one all the time. This one, reduce and multiply, you can only do when applicable. Let me give you an example. Well, you can do it here. 1/2 times 7 over 8. Can you cancel anything out there? No. You can only cancel diagonally and vertically. Well, 1 and 2, you can't cancel anything there. 7 and 8, you can't. 2 and 7, they don't go into anything. So you can't cancel, so you just do it. 7 over what? 16. So that's an example of not being able to reduce, just like this one. You can't do anything with this one either. So there's sometimes the only thing you can do is just multiply. All right? So what's one reduce? Here's one. 1 over 2 times 4 over 5. Now, I can't cancel anything here. I can't cancel anything here. But I can cancel what? The 2 and the 4. 2 will go into 2 how many times? 1 and 2 will go into 4 2 times. 1 times 2 is, and 1 times 5 is, and that's an example of reducing, then doing it. Or reducing and multiplying. Does it matter which way you do it? No, I don't care. You do whichever one you want. Just make sure you get the right answer. Okay? That's how you multiply fractions. What about division? Is there such thing as division by fractions? No, there is not. Why isn't there anything about division of fractions? Because you multiply by the what? Reciprocal. Reciprocal is a 25-cent word for flip-flop or inverse. Okay? So let me give you an example. 1/3 divided by 4/3. Well, there is no such thing as division by a fraction, so we rewrite it. How do you rewrite it? Well, you go from left to right. You rewrite 1/3. You do not divide, you what? Multiply by the what? Reciprocal means that you flip it. And this time, what happens to the 3's? You can cancel them. And what's 1 times 1? 1. So that'll go in 1 time, and that'll go in 1 time, and 1 times 4, you get 1 what? 4. Now what's 1 times 3? 3. What's 3 times 4? 12. And you reduce that, what do you get? So either way you do it, you should get what? 1/4. Let me show you one you'll see on a, and this is a, what do you call, standardized test. This is one you'll see on a standardized test, and people will look at it and go, huh? The reason I know this is I was tutoring somebody that was taking the Triple E, which is, that's the, when you finish Clemson, you take the Triple E. That's the test you take to make sure that you can teach. And she failed it like twice. And the reason she failed it was because of the math. And she said, this is a question I don't know how to do. Why? Why do you think that she just didn't know how to do it? She just leave it blank. Why did she leave it blank? Why was she confused? Because it's the way it's written. Yes, it's the way it's written. What you should do on a problem like this is take your handy-dandy virtual red marker and make that the big fraction bar. Then you should take your blue marker and make this fraction down here a what? Make this whole number a what? Fraction by putting a 1 in it. Now you have a regular problem that says what? 4/3 divided by what? 4/3 divided by 4 over what? Well, we don't multiply, we don't divide by fractions. We multiply by the what? 4/3 multiplied by the what? And what happens to the 3's? And what's the answer? 4 over 4, which is, that's a standardized test question. On any of your SATs, ACTs, entry level into Michelin, entry level into nursing program, anytime you have to take a standardized test, that's the kind of question you'll see. I'm sorry, I just had a brain bubble. I'm sorry. My bad. So that'd be 1/4. Thank you. You're supposed to say your 1/4. I know. Okay, what cancels now? The 4's cancel, and it should be 1/3. Got ahead of myself. 1/3. Thank you. Now, is that the type, you may see one of those on the test because just out of the, standardized test. But what are you going to see on the test? I'll show you. Let me go to the study plan. Some people in these chairs. Oh. Let's take our handy dandy
So Isaiah's going to be on chapter 5 only, right?
I don't know. I have no idea. I should give y'all a handout that has the Unit 1 on it. What should I call it? The syllabus. That's what I should do. And I should put it in a form and y'all should put it on the front of y'all's notebook.
I can't remember about it. I got it, I can't remember.
I'm picking on you, Miss Burton. I think it's 5.1, 5.2, 5.3, 5.6, and 11.1, I think. You'll have to look.
I can't remember about it.
Let's go and pull up your homework so we can discourage you. Let's go with... Well, I'm not going to pull up your homework because your homework is real easy. So I'm going to pull up some study plan problems, and whatever I cover, you should be ready for. Let's see. And 155 and chapter contents, our ebook, chapter 5.3, study plan. Because we did some of these the other day, but we didn't move into the problems of multiplication and we did these. So let's see, where are they? There we go. All right, so please excuse my dear Aunt Sally. You got to do parentheses first, so go ahead and do parentheses. So that would be, do the multiplication first. I believe you can reduce there before you can do anything. What do you mean? Yeah, you missed about the first 30 minutes of class. I don't know. I don't even know what time it is. Let's see, class, we started about 10 till. Yeah, so it's, yeah, you missed about 30 minutes of class. So yeah, you missed quite a bit. That's why you had the video. Huh? All right. So, 1/3 times 12 over 13 plus 1/7. Now, with multiplication, I can cancel. So, 3 will go into 3 one time, 3 will go into 12, how many? 4 times. So, what's 1 times 4? 4, and 1 times 13 is, and now I'm going to add 1/7, so I've got to have a common what? Well, both of those are what? What's 7 and 13? They're prime, so just multiply them together. Thing old, what, 91? So 91, or you can do this. Put 13 times 7 right here. And 13 times 7 right here, which is 91. I'm just writing it out longhand. And how many times will 13 go into this? 7 times. 7 times 4 is 28. How many times will 7 go into this? 13 times 1 is, now, if you didn't want to do it that way, you could put 91 down here and do it that way. However you want to do it, I don't care. Okay? Because 13 times 7 is 91. What's 28 plus 13? 41, Hubert. That's right, class. 41 over... Okay? So let's take our handy dandy answer and punch in and see if we're stupid. 41 over 91. Might be divisible. Look there, we got it right.
So you said, you got like 91, and then 13?
13 will go into 91. How many times? 7 times. 7 times 4 is 28. 7 will go into 91 13 times. 13 times 1 is 13. Let's do it in there. Did it do another one? No, that's not. I'm not going to do the same one. So let's do. All right, try this one. Now look closely. It says 3 minus 1 over 15. Now what are you going to do first with that 3? Put it over 1 and put that 6 over 1. So 3 over 1 minus 1 over 15 divided by 6 over 1 plus 1 over 5. Go ahead and write it out. That's the first thing you need to do is write it out. Yep. Division. 3 over 1 minus 1 over 15 divided by 6 over 1 plus 1 over 5. Now I have a question for you. Should you get one denominator all the way across, or should you get 2 denominators? Huh? You have a choice. You can get 2 denominators, which would be 15 and 5, or you can get one whole denominator and just do 15. Which one you think is going to be easier? One denominator will make things a whole lot easier. So I am going to get a common denominator of what? 15. And I'm going to change everything over by using 15. So 15 here, 15 here, 15 here, and 15 here.
You want me to, mark out the 3 and the 15 and put 3 and 5?
You can't do that. You're adding and subtracting. Adding and subtracting, you have to have a common what? Denominator. And you're also supposed to do what's in parentheses first. Parentheses, you're subtracting. Parentheses, you're adding. And once you do the parentheses, then you do the division. No hiccup in the class. Now, some of you that have had a musical instrument, how many of you play a musical instrument? What do you play? Okay. Let's say that you go to your instructor, and your instructor shows you how to do an F. Okay? An F is really difficult to do. And you do an F for your teacher 5 or 6 times, and then you go home and you watch TV for a week, and you finally try to start practicing your F, which is difficult, right before your next lesson. Are you going to be good at it, or are you going to suck at it? You're going to suck at it. So if you suck at something and your instructor shows you how to do it, what should you do when you get home? Watch TV? Practice as soon as you get home, and do homework on those problems that you suck at. Okay? Because if you don't, the next time you come around, which will be next Monday, you'll have class Monday and Wednesday, right? You're going to have class Monday, and you're going to come in here and you're going to try to do a couple of these problems right before class, and you're going to say, I don't understand. Well, no, you don't understand because you haven't done it. You haven't worked at it. You haven't practiced it. So when you have a musical instrument type problem, which these are, you're going to have to practice them at home. You can't just come to class and go, okay, and then come back next Monday and say, yeah, I know how to do it. That ain't gonna happen. So, how many times will 1 go into 15? 15 times 3 is 45, Hubert. That's right, class. How many times will 15 go into 15? 1 times 1 is 1. How many times will 1 go into 15? 15 times 6 is 90. And how many times will 5 go into 15? 3 times 1 is, okay, take a minute and finish it. Excuse me. What's 45 minus 1? 44 over 15 divided by, what's 90 plus 3? Okay, now finish it. Do you divide by a fraction? No, you multiply by the reciprocal. So I'm going to rewrite this. 44 over 15. Look at that. The 15s are going what? Why do they cancel out? Because you made one common denominator of 15. That's why. It's a little trick I learned in the war. Over 93. Now you take your handy dandy red virtual marker and you cancel those what? And you get 44 over 93.
Okay, you,
Huh?
you go on the last one, you convert in 5, but whatever. You go to 5 to 15, and then 15 to 1, and then 1 to 3.
Yep. I go. How many times will 1 go into 15?
On the very last one.
This one?
Yeah.
How many times will 5 go into 15? How many? 3 times 1 is 3. And we go and check to make sure we know what we're doing and to get positive feedback so we can feel good about ourselves. 44 over 93. I think that's in lowest terms because 93 is not a nice number. 93 is divisible by 3 and that's it. 3, what is that, 31 times? But 3 won't go into what? 44, so I think that's pretty much it. And you feel good about yourself. So you don't put on too much makeup and have orange face and white neck. Oh my, word problem. Will you have these on the test? Yeah, about 5,000. But look at it. Is it hard? No. It says a man is 61 and 5/12 inches tall, and his son is blah, blah, blah. How much taller? When you see the word taller, anything with an ER on it, what are you going to use? Taller. Subtraction. You're going to subtract the smallest number from the what? Biggest number. Shorter. How much shorter? How much taller? How much heavier? How much lighter? Anytime you got an ER, that means you're going to subtract. So I'll set it up for you. 61 and 5/12. You might have to BORRY. I don't know, but you might have to. What does BORRY mean? Barry? That's not a word, Hubert. Shut up. It is down here. I'm setting it up this way so we can do the big Z. Some of y'all like to use the Z, so we'll use the Z. All right, what do we have to get? A common what? Denominator. I'm going to let y'all do this one and then we'll work it together. All right, we don't know what the common denominator is, so we got to figure it out. 9 and 12. 3, be 3 and 4. 3, 1 and 4. 2, 1 and 2. 2, 1 and 1. 4 times 9 is what? 36. So we put a 36 right here and a 36 right here. Now, I'm not worried about the whole numbers because you can subtract whole numbers. The only thing I'm worried about is the what? The fractions. So, how many times will 12 go into 36? Well, 4 times 3 is 12, so how many times? 3 times. 3 times 5 is what? 15. How many times will 9 go into 36? 4 times 4 is what? Uh-oh, we got a problem. What's the problem? You can't take 16 away from 15. Well, Hubert, I thought you said in 5.2 we could and get a negative number. Yes, but measurements cannot be what? Negative. Any of y'all ever seen anybody that's negative 4 foot? Okay? You can't do that. So we got to change that. So we have to borrow. Borrow is a word that y'all grew up with, right? When you borrow on big numbers, you take one away from the big number, it's called borrow. And borrow, depending on where you're from. So we've got to borrow a number to add to this one to take away 16 because that number's too small. So I'm going to borrow 1 from the 61. I'm going to borrow 1. And that'll make that 61 a what? 60. And that 1's floating around up there. I got to bring it back down. Now, since we got 36 in the denominator, I'm going to bring that 1 down as 36 over 36. Now, my new problem looks like this. And don't worry, we're going to do several of these. So now I've got 60. And what's 36 plus 15? 51. Subtract 59 and 16, 36. What's 60 minus 59? And what's 51 minus 16? 35. Somebody tell me how close he is, how much shorter he is than his father. And don't say 1 over 35, 36, because nobody talks like that. What's 35 and 36? If you get these two numbers, if these two numbers are close to each other, what's it close to? 1. So 1 plus 1 is what? He's about 2 inches shorter than his father, or whatever. The man, blah, 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 his son, yeah. The son is 2 inches shorter than his father. Now, this problem people usually have trouble with. Why? 1, because they don't know how to read measurements. That's one reason. They don't know how to read tape measure. 2, they don't know how to get a common denominator. And 3, they don't know how to borrow. I'm sorry, borrow. That's why they have problems. So let's do a nerding. Now the 2 inches, I'm telling you, that's what 1 over 35, 36, that's what that's close to. Anybody ever seen a set of wrenches? 7/8. What is 7/8 close to? An inch? 15/16. What's 15/16 close to? An inch. 3/4 is not close to an inch. 3/4, they're not, those two numbers are not, they're low numbers. But 15/16 and 7/8 and 35/36, 21 over 22, 35 over 36, 38 over 39, those are all numbers close to 1 inch. So your answer is, you got to hit your mixed number thing right here. 1 and 35 over 36. And I feel good about myself. Similar question.
What happens if you get 2 in it?
We're going to get it wrong. This is just close to 2 inches. It's 1 over 36, 1/36 from 2 inches, which 1/36 is less than a tick mark on a measuring tape. So it's real small. That's right at 2 inches, right close to it.
You want to put 2 on the test and
No, you put 1 and 35/36. I was telling y'all that this is close to 2 inches because these two numbers are so what? Close to each other. If this was 31 over 36, it wouldn't be close to 2 inches. If it was 18 over 36, it wouldn't be close to 2 inches. But since it's 35 over 36, that's right up next to 2 inches. Okay? All right, look at this one. Let y'all do this one. And you'll have to borrow. This one says, let me blow it up because somebody will say, I can't say it, I can't say it. Hold on a minute. What were you questioning? Does somebody have a question? There you go. I'll read it. A woman is 68 and 1/18 inches tall, and her son is 64 and 1/4 inches tall. Subtract them. No. Well, 68 minus 64 is going to be 3. So it's going to be around 3 inches.
Did you borrow again?
You're going to have to, yeah.
For that?
36 be 38. Looks like this looks right. Looks right.
Really?
Mm-hmm. I'm impressed.
You should be good, right?
But I don't know, I haven't done it, but that looks like you did everything correctly. 68 and 1/18 over, minus 64 and 1/4. Common denominator is what, 36? So I'm gonna put a 64 and 36 here, and a 68 and a 36 here. I'm just doing it a little bit different. You don't have to do it this way. 4 will go into 36 how many times? Huh? 9 times 1 is 9. 18 will go into 36 twice. 2 times 1 is 2. So that doesn't help us because you can't take 9 away from 2. So I'm going to borrow 1 from this 68, and I'm going to make that a what? 67. And I'm going to bring that 1 down as 36 over what? So now my new problem is 67 and 38/36 minus 64 and 9/36. And 67 minus 64 is 3. And 38 minus 9 is 29 over 36. Now, let's talk about this. What is this? Is it close to 4? No. Why? I'll change that into a 30. Why am I changing it into a 30? Because I'm changing the problem or because I'm estimating? I'm estimating. I'm thinking in my head. 30 over 36. Somebody divide that out. Well, 30 over 36, that'd be what? 30, that's 15 over what? 36 will be what? 18? 13 over 18? It's about 3/4. Comes out to be about 3/4. Do another thing. Change that to a 27. Divide 27 and 36. What do you get? Well, 3 will go into 27 9 times. 3 will go into 36. What? How many times? 12, right? 9 over 12 comes out to be what? 3 over 4. So it comes out to be about 3/4. So how many inches is this? 3 3/4 what? Inches. That's about 3 3/4 inches. That's how you estimate. Nobody is going to walk up to anybody in Lowe's and go, I need a board that's 3 foot, 29 36 inches. Nobody. You're going to walk up and you're going to ask for 3 3/4 inches because that is close to 3 3/4 if you simplify the math. Yeah, the 29 over 36. Okay? And I'm not going to type that in. I'm just going to type in 3 because I'm lazy today. 3. And I'm going to quit school and live in the ditch because I got it wrong. 29 over 36. So we did get it right. Okay? What else we got? All right, look at that one. This one says a stairway consists of 10 stairs. Each stair or each step is 7 and blah, blah, blah high. What is the vertical height? Okay, stop. Let's say that you got some cement blocks. Each cement block each cement block is equal to 1 foot. In other words, each cement block is 1 foot high. Everybody with me?
Are you drawing it?
No, I'm using an example. All right, cement block. Everybody knows what a cement block is, right? It's that gray thing that's about this long. Let's say that each cement block is 1 foot tall. And I've got 10 cement blocks. How high can I stack those cement blocks? Okay, it's supposed to be real simple. You're supposed to say, oh, that's so blah, blah, blah. Okay? Each cement block is 1 foot tall. And I got 10 cement blocks in a pile and I want to stack them. How many? How'd you get it? You did what? Multiply. So what are you going to do over here? Multiply. I'm trying to show you the association between an easy problem and a more difficult problem. All you have to figure is what operation. What operation do we use with this one? Wait a minute, hold on. What operation when you see the word taller, wider, subtraction? This one, what is the vertical height? Remember the cement blocks. What are you punching in?
I took a picture of my dog.
Okay. Just making sure you ain't texting or using the calculator.
No, no.
Okay. All right, let's go. Do it. So ignore this now. This was just to show you that you need to multiply. And I want you to multiply these two numbers. Now there's several ways you can do it. So I'm just going to tell you that right now. What have you noticed what I've done? What did I do different from the problem? I made 12 into a what?
Fraction.
I made 12 into a fraction. Now what do you think my next step is? Huh? Change the 6 1/8 into an improper fraction. Now that's what I'm going to do. I don't know. You have 6 times 8 is 48 plus 1 is 49/8. And that's what I would do. I'm going to get you some orange juice and some chicken soup. Well, we're gonna talk about that. Let me just wait. So, we get 12 over 1 multiplied by 49 over 8. We can reduce. 4 will go in there 2 times. 4 will go in there what? 3 times. So this ain't too bad, because 3 times 49, all of you should be able to multiply 3 times 49. 3 times 50 is what? Minus 3, 147. So everybody should be able to do that. 147 over, and what's 1 times 2? 2. Now, nobody in their right mind is going to walk into Walmart and ask for 1/47 halves piece of rope. Okay? What are we measuring in? Anytime you measure something, name something that you measure besides height. What else? What do you measure? Huh? Height, weight, distance, volume. Okay, everybody got that? You use mixed numbers. That's the only time you use mixed numbers, is when you're dealing with a unit of measurement. Think about it. When do you see 4 2/3? When do you see that? Cup of sugar, cup of flour, 3/4 of a gallon of OIL. Okay? 3/4 of a mile, half a mile, 1/2 a mile, 3.5 miles, 1/2 miles. You never see 3 1/2 when you do a problem 5 times 20.5 is equal to whatever, and you say, okay, I need to put that in a mixed number, and you're not measuring anything? No, you never put things in mixed numbers. The only time you use a mixed number is when you're dealing with a unit of measurement. So, how many times will 2 go into 14? 7 times. That leaves a 7, right? 2 will go into 7 how many times? Leaves a 1. 2 will go into 10 how many times? And no, you should not use a calculator on that, because there's no reason to. If you use a calculator on that, then you're just hanging a sign around your neck that says, I can't do simple math. All right, let's do a nerd.
That's what you're gonna enter in the thing, so
I guess, yeah. So, well, it says type as integer, proper fraction, or mixed number. So 73 1/2. Mixed number, 73. Oops, I hit the wrong button. This one. 73 1/2. Fantastic. All right, try that one. It says, I have no idea what it says. It says, to repair his sprinkler system, Tony needs blah, blah, blah inches of pipe. He has on hand these 3 pieces. How much more does he need? Well, these 3 right here, you're going to add them together and subtract it from this, and that's the piece you're going to need. Okay? So add those 3 together, subtract it from that. Should you get a common denominator of 16 before you even start? I would, because it'd make life a whole lot easier. Or you could just quit. Throw your pencil down. Live in the ditch. Yeah, I'm gonna change everything to common denominator. 20 and 9/16 minus parentheses 2 comma 16, or 2 fraction bar 16 plus 3 fraction bar 16. Why am I doing this? I'm doing it to make you mad, or I'm doing it to make life easy at the end of the problem? Make life easy at the end of the problem, and you won't have to rely on what? Calculator. Oh, I'm sorry. Hold on. How many times will 4 go into 16? 4 times 1 is? How many times will 8 go into 16? 2 times 5? And how many times will 4 go into 16? 4 times 1? All right, y'all finish it. If you can't finish it, just consider yourself a loser. What's 2 plus 3 plus 6?
11.
And 4 plus 10 plus 4?
18.
Okay, now there's 2 ways to do this problem. One is to do it just like it is and borrow, or you can change them into what? Improper what? Improper fractions and finish it. I don't care which way you do it. I'm going to borrow. So if I borrow 1 from the 20, it'll make it what? And turn that 9 into what? 16 plus 9 is what? 25, Hubert. That's right, class. You could. You still get the same answer. Doesn't matter. You can do which one you want. All right, what's 25 minus 18? 7 over 16. And 19 minus 11. So he needs a piece that's about 8.5 inches long. Why did I say 8.5? Because what's 2 times 7? So 7/14 is a half, right? So what is 7/16? A little bit over what? A half. Now, let's do it the other way. 20 and 9/16 minus 12 and what? 2/16? No, you don't change it to 16ths. Why? You've got to have the same denominator. So 9 minus 2 is what? 7. And what's 20 minus 2? 8. Same answer. Isn't it a miracle? So our answer is 8 and 7/8 inches. 8 and whatever. 8, well, and 7/16. And we feel good about ourselves. What do you think? That's 47 out of 50. We got 3 more to go, but we can do those later. Just remember, we're on 48 out of 50. We got 2 more to finish up this section of homework. So we'll finish those next time and go into the next section, which is 5.6. Okay?